Another term that we frequently use while talking about relational databases is the ACID properties of the database. ACID is an acronym for Atomicity, Consistency, Isolation, and Durability. Atomicity means a transaction either completes or fails in entirety. There is no in-between state. Nobody sees a partial completion of a transaction. Consistency means the transaction leaves the database in a valid state. Isolation means no two transactions mingle or interfere with each other. The result of two transactions executed in parallel would be the same as sequential execution. Durability means the changes of a transaction are saved. It remains there even if power is turned off. Every relational database such as MySQL, PostgresqL, Oracle, and Microsoft SQL guarantees ACID properties of a transaction. Let me take you through a typical story before NoSQL. On the initial public launch, we will move the database from a local workstation to a shared, remotely hosted MySQL instance with a well-defined schema. This is our beginning. Soon enough, our service becomes popular and we have a problem. There are just too many reads hitting the database. This is quite usual with any server. And the solution is pretty simple. Start caching frequently executed queries. We generally use memcached for caching, but note that the reads are no longer acidic. The moment we have two places for data, it generally becomes inconsistent. It would take some time to update the cache. Until then, the cache will be serving older data. If the service continues to grow in popularity, then too many writes would hit the database. To solve this, if we have money, we would vertically scale our hardware to say a 16-core processor, 120 GB RAM, and banks of really fast hard drives. Soon enough, new features would increase query complexity. We will have too many joins. If you take a look at Amazon detail page, there are more than 100 features on the page. If each feature was in its own table, to prepare such a page, hundreds of joins will be required. So you start denormalizing in order to avoid joins between the tables. Yes, denormalizing. If you are from a DBA background, this is going to be a very hard moment. If the service continues its popularity, it will swamp the server again. Things would become too slow. So we should stop doing server-side computations such as stored procedures and move those to client-side. For example, datetime computations. Even after this, there will be some queries that are slow. So we periodically pre-materialize the most complex queries and try to stop joining in most cases. Pre-materializing means keeping the results of the query that are often required ready. Now the reads might be okay, but writes are getting slower and slower. So you drop the secondary indexes and triggers. Now at this point, you will realize that your DB is left with no ACID properties due to caching, no normalized schema, no stored procedures, triggers, and secondary indexes. Now the question is, why do we need a relational database then? That's why NoSQL databases originated.